Welcome everyone to this Unreal Engine 5 tutorial. In this video you will learn how to properly build a SaveGame functionality, where you can save the state of your game and have it loaded back when you close and reopen the game. Now you may have created save functionality before, but my goal in this video is to teach you how to properly structure your code so that you can extend the system to multiple projects easily, so you can maintain it, add functionality to it, all using good software engineering practices. We will cover how to add checkpoints to your game that once the player reaches, we save the player's current state, like their location, stats, and what weapon they were holding. We will cover how to save actors in your level when you spawn, update, or destroy them, like these cubes here. And we will discuss the difference between synchronous and asynchronous save and load functions of Unreal Engine, and we will implement a system that supports both of them. And finally, we will add UI indicators that the game is being saved, like the one you see here on the bottom right of the screen. And we will be using interfaces and structs to have clean and maintainable code, all using good software engineering practices. So let's get started. Alright, so I made a sample level here, just this tiny obstacle course, as soon as we press play, 3 cubes spawn. The player can also press C to spawn cubes or X to delete them. I can press 1 and 2 to change weapons. Now this is all just dummy functionality to test our save functionality with. I can press T to take damage, as you can see on the bottom left here, I'm taking damage, or I press H to heal. Now, of course, as we play the game now, and I stop and I play again, everything resets. With our save functionality, we want whatever the state of the game was when we save, whether I took a certain amount of damage, which weapon I'm holding, where I am in the level, how many cubes I've spawned, and so on. When I exit the game and I play again, I want all of this information to be saved. So let's see how we can do that. All right, so first thing we want to do is create a folder. Let's call it SaveGame. And the first class we're going to create is something called a SaveGame class. So search for blueprint class, open all of the classes, and search for SaveGame. Now I'm just going to call this BP SaveGame. And this is the class that holds the structure of the data you want to save. So we're only going to add variables in this class, and these are the variables that we need to know or we need to save about our game to be able to recreate the state of our level perfectly when we stop the game and start it again. So this is the data that you need is going to highly depend on the type of game that you're building. But what you need to do in this stage is think, what kind of data structures or what kind of information do I need to be stored once the game is closed? So in my case, for example, I want to store everything about the player. Their location, what weapon they were holding, which direction they were facing, what was their health at the time, if they took damage. Yeah, and that's it. And for example, the cubes, I want to store each cube, where it was, and yeah, what's its location or its transform. So for now, using these 2 pieces of information, I can recreate the state of the game. So let's start with the player first. Now, instead of going here and adding a variable for location, a variable for health, and so on, I really recommend you create structs in this case to make your save object a lot more readable and easier to use. And let me show you how we're going to do that. So we're just going to open our SaveGame folder here and right-click and create a new structure. And we're going to call this s_player_save. If you don't know what a structure is, it's just basically a collection of variables that you can reference as a single variable. So the first thing you want to know is the player's transform. So transform is location, rotation, and scale. So just search for transform. The second thing we want to know about the player is which weapon they were holding. So we only need the class of the weapon. So we're going to say weapon class, and this is going to be of type BP weapon. This is just the class that I have. And make sure it's class reference, not object reference, because we need to know the class of the weapon, whether it's a sword class or an axe class. and they both inherit from weapon base. So that's why this is weapon base. And the health of the player at that time, which is a float. And I also mentioned that I want to know which direction the player was facing. The transform will tell me the direction of the mesh, but not of the camera. So I need to also store the direction of the camera. So if we stop the game while the camera is facing a certain way, we can recreate that once the game starts again. So I'm just going to add something called a control rotation. This is the rotation of the controller object that the player is being controlled by, which gives us the camera rotation in that case. And it's just going to be of type rotator. All right, now back in our BP save game, I'm going to add a variable here and call it player save. And it's just going to be of type S player save, this new struct we created. So now, whenever I want to save the player, I know that this is the information in this structure is what I need to save and load to be able to recreate the player state. Now, the second thing I mentioned is the cubes. So we have cubes that we can spawn, we can delete, we can even push them around, right? So how do we know if you want to recreate this exact state? I need to know the transform of every cube that I have in the level. So here, what I'm going to store is an array of transforms, where each element of the array corresponds to a different cube. So just create a variable, call it CubeTransforms, and it's going to be of type transform. And make sure to go here on the right and change the type to array. So we have an array or a list of multiple transform objects. And then we can loop over that array and recreate or respawn our cubes from it. Now that you have the data that you want to store, how do we actually save and load this information? Now, usually the event graph in this save game class we leave empty. So let me show you in another event graph. Let me open up my third-person character. I'm just using it as an example. We're not going to be doing this here, but I want to show you the functions. So we have a function called LoadGameFromSlot and another function called SaveGameToSlot. Okay. Now, SaveGameToSlot takes a SaveGame object. This is the BP SaveGame we just created here. And takes a slot name, because maybe you can have multiple saves, like slot 1, slot 2, and so on, and the user index, because you can also have multiple users. Think of PlayStation accounts, for example. And you give it an object and it saves it. It actually saves it as a file on your computer. And I'll show you in a bit where that file is if you want to delete it to remove the save. And load SaveGame from slot does the same thing, takes a slot name and a user index, and it gives you back the SaveGame object. So it gives you basically these two variables back in an object. Now I also want to talk about the load SaveGame async and also async SaveGame to slot. So the difference between the normal one and the async one is that if you have a lot of data that you're trying to save, this operation is actually reading, the load one is reading from your hard disk, and the save one is writing to your hard disk. So if you are saving tens of thousands of objects, then this may be slow. So the async, what it does is runs this operation in the background and lets you know when it's completed by following this pin. And also it still gives you the same SaveGame class and a Boolean whether it succeeded or not. And the SaveGame as well, if you want to save something that's going to take a long time, you just want it to save in the background while the game still continues, then it gives you a completed pin when it's done and the SaveGame object and success. So in our use case, we're going to implement a system that supports both sync and async, and I'm going to show you how we use both. For loading, I recommend loading synchronously because you often want to load things before the game starts. But for saving, maybe you want to save something while the game continues, but we're going to discuss this in more detail. Now, you probably saw a lot of people just using these functions within the third-person character or the level blueprint, but I want to show you the proper way of doing it. We're not going to be calling those here. To understand the best place to store this or use this information, it's good to understand what happens when you start the engine. So very quickly, this is taken from the documentation of Unreal Engine, and this shows you the flow of execution. You don't really need to understand anything here other than the fact that when you start the engine, whether as standalone or editor, one of the first things that is created is this GameInstance object. So you see here the GameInstance is created before anything else. And this is important because the GameInstance is an object that handles the current state of your game and persists throughout levels. So as the player is moving from one level to another, the GameInstance object stays the same. So we can load our save file on the GameInstance initialization and keep it there. As the player moves through different levels, the same information is loaded. And to do that, we're going to create a custom GameInstance object. So open up your content folder, right-click for Blueprint class, and search for GameInstance. And I'm just going to call it BP GameInstance. And before opening it up and doing anything, we actually want to tell the project to use our own custom GameInstance. So go over to Edit and Project Settings, search for GameInstance, and here in the first one, the GameInstance class, you want to change it to your custom BP GameInstance or whatever you named it. Excellent. So now the first thing we want to do is load the game when the GameInstance is initialized. And inside the GameInstance class, you can search for an event called init. And this event is called as soon as the GameInstance object is initialized. All right, now the first thing we want to do is first make a reference or have a variable that references our save game. So I'm going to create a variable called SaveGameData or just SaveGame, and this is going to be of class BP SaveGame object reference. Now inside the GameInstance, I can use the functions that I told you about. I can just say LoadGame from slot, and whatever object we have here, then we we have to cast it first to our BP save game and set the variable. And the slot, I can just give it a name. Let's say, slot name here. Compile to give it a default, let's say slot 1. And user, I'm just going to keep as 0. Now I can do this and this will work. But the problem is now every time I want to get information out of this GameInstance, let's say in my third-person character, I have to get the GameInstance, this is the function that comes with Unreal Engine, cast to my custom BP GameInstance, and then get our save data. I don't want to cast every time I try to access our save data because I know it's always going to be in the GameInstance. So to avoid casting and to make sure that the third-person character doesn't have to do this, we are going to use interfaces, which is usually the cleaner way of doing this. And let me show you how this is going to look like. So opening up our save game folder again, right-click anywhere and search for interface. And we're going to create a blueprint interface and call it BPI save game. Now, an interface describes functions or functionality that we want a class to have. So we just create the function names and inputs and outputs, but we don't implement them here. So the functions that we're going to implement in the save game instance, at least the generic ones, are LoadGameData and a new function called SaveGameData, and a third function called GetGameData. All right, so one function to load, one function to save, and one function to get. Now I'm going to add some inputs to it. Now the LoadGameData, I wanted to take a Boolean called async. Remember, I told you we're going to support both synchronous and asynchronous calls, and this is how we're going to do it. If we set this bool async to true, then we do an async call, and if we set it to false, we do a normal sync call. And I want the save game to also have the same variable async. And the GetGameData doesn't take any input, but has an output, which is our SaveGameData of type BP SaveGame. This is the class that we created, which holds our save structure. For now, this is my blueprint interface, nothing more. Now going back to the GameInstance, let's delete this. and go to class settings. And if you go to the right here under implemented interfaces, add the SaveGame BPI SaveGame that we just created here, and it will automatically add the functions that you've created in this interface for you to implement here. Oh, but I have an error collision in name. Oh, I called this SaveGameData, and there's a function called SaveGameData, so we should rename this to just saved data or something. You can't have a function and a variable the same name. All right, so now we just need to implement these functions and start calling them here. So GetGameData is very simple. It just returns this saved data reference. And now the SaveGame and LoadGame. Let me start by showing you the LoadGame first. How are we going to load the game? Well, first, ignoring the async, the first thing you want to check before loading a game is, does a SaveGame exist? And there's a function for that, calls does SaveGame exist? And this takes the slot name that we have here and the user index. And it tells you whether this exists or not. So first of all, if it doesn't exist, that means we're trying to load something that's not there. All we do is create it. So create SaveGame object, and the class is BP SaveGame. Then we want to just set this variable, the SaveData variable. The nice thing here is when you give it the class name, it makes sure the output pin is the same as the class, so you don't have to cast. And now for the true scenario, we want to check. This is where we check the async. So if async is true or false. So if it is async, then we want to load game from slot. What's it called? Async load game from slot. Give it our slot name. And on completed, here, we need to cast this to our BP SaveGame. Make sure to do it on completed, not on immediate execution. And then set this saved data variable. And for, this is async. And for the non-async, we're just going to do load game from slot, the regular one. Give it the slot name as well, and these two will be the same. Now, one very important distinction here is this doesn't happen instantly. So if someone is waiting for the game to load in the background, we need to notify them that the game has loaded and they can start using this data. Instead of maybe checking every few seconds if the game is loaded, the best thing to do is use event dispatchers. So over here, I'm going to create an event dispatcher, call it on game loaded. And over here, we just call it and we say, okay, on complete, we set the saved data and we call on game loaded so that maybe another class binds to it, listens to this event. And once the event is called, they can access the saved data. And of course, I'll show you examples of how we're going to use all of this. And here we don't need this because it happens instantaneously. Perfect. So this is our load game. Let me just comment it. Load game. And then we have our save game. Now the save game is very simple. We just do a branch, check if async or not. And if async, we do async save game to slot. And if false, we do regular save game to slot. And the save game object is the same. Oh, sorry, it's a reference. So the save game object is saved data for both. So whatever variables are currently stored in this reference, this is what we'll be saving at this point. And the slot name for both is this variable. And that's it. Let's call this save game. And we're going to expand on these a bit later on. But now, the first thing we want to do on init is call LoadGame. LoadGame. And make sure that async is not true, because this is the GameInstance class. Nothing has loaded in the game. first thing we want to do is load our game data, and we want it to be synchronous, meaning it blocks the execution. So the level doesn't load and the player don't load until the game data has loaded first, because you need the game data to know where to put the player and what to spawn in the level. I can show you a way to do it async at the end of this video, where you can add loading screens and so on. Now that we have a function to save our game and we're loading our game when the game instance is initialized, let's actually use this in our level. So for example, I want when the player reaches any one of these orange platforms that we save their location, so sort of as a checkpoint. So what I'm going to do is create a checkpoint actor for this. So over here in our SaveGame object, I'm going to create a blueprint class of type actor and call it BP checkpoint. Open it up, and it's just going to have a sphere collision, nothing else. Drag the sphere to make it the default object. And that's basically it for the checkpoint. We're going to check when the player collides with it. So let's add our checkpoint over here, and let's make the sphere a bit bigger. Hard to see with this orange color. Yeah, something like that. And then let's duplicate it. Add another one here. And duplicate that one. And add a final one here. All right, so we have these 3 checkpoints in place. And as soon as the player reaches any of the checkpoints, we want to save all of the player data. So opening our checkpoint class, we're going to check sphere here. Click on the sphere and scroll all the way down on the right. You'll find on component begin overlap, and click the plus icon. So this is what happens when anything overlaps with the sphere. First, we want to check, we want to cast this to our third person character or your player or whatever, and check. If this is true, then the player has reached the checkpoint and you want to save. Technically, I have a function that I can use anywhere called GetGameInstance, GetGameInstance, and I can just call SaveGameData. Right? And you'll notice SaveGameData doesn't take an input because it automatically saves the variable that's called SavedData. So I can get SavedData, I can update the player. I'm not going to do it, I'm just showing an example, and I can get the set player save, and then make player save, put in all the information, and after that I call save. That's a lot of things that the checkpoint needs to know about the save data. That's not really proper separation of concerns. The game instance knows everything about the save data, not the checkpoint. The checkpoint only needs to know that I want to save the player's data. So at this point, the checkpoint just needs to do is call something like save player data, right? And that's exactly what we're going to create. So go back to our BPI save game. This is the interface where we have these 3 functions. And by the way, these 3 functions are now common for any project that you create, for any game that you create. And now we're going to add logic that's specific to this game or this project. And this is how you can expand on this system. So I'm going to add a function and call it save player. And it takes as input the player save data, which is the structure, so our SPlayer save struct that we created. And then as we compile and go back to our game instance, we're going to be asked here to implement it. So if we double click on save player, what we're going to do is, oh, and I also forgot one thing. I also want to add the option to make this async or not, and that will be a Boolean. All right, so what we want to do here is we have this player save. So we are going to get our save data. We're going to set the player save to this new player save. And thus we just updated the save data. So when we call SaveGame here, SaveGame, pass in async is true or not, then it will automatically get the new save data that we just updated and stores it. Excellent. So now our checkpoint, all the checkpoint has to do is get the game instance and call SavePlayer. And I didn't have to cast because it's an interface function. Great. Now the last thing we need to know is what is the player save data? And who knows this player information? It's the third-person character. So in the third-person character, we're going to create a function that's called GetSaveData, or I don't know, getPlayerSave, something like that. And it has one output, which is the player save, and it's the structure that we created, s_player_save. Then if you right-click and split, you can right-click and split or pull and say make. Both are the same. I'm just going to right-click and split. And then we're going to just plug in the information that we need. So get actor transform. That's going to be our transform. We have an equipped weapon reference here. So we're going to get this and get class. This is our weapon class. And the health, we'll just take the health variable from here. And the control rotation, there's a function called getControlRotation. Lucky for us. Excellent. So now back in our checkpoint, before we save, we just have to call getPlayerSave from our player and plug that in. And then you can decide whether you want it sync or async. In this case, it won't really matter at all because the synchronous speed is almost instantaneous. We're saving very little data. So I'd keep it sync here, not async. Awesome. So I'm just going to show you that I'm going to print here saved player data, and we're going to play. Now, as soon as I walk to a checkpoint, you see that it prints on the top left saved player data, right? But if I close the game and I start again, I don't start at the checkpoint. Well, because we didn't use the save data. Now we're just saving it somewhere in the file, and we are loading it in the game instance, but we're not using it in the player. So let's see how we're going to do that. Back in our player here, I'm going to, just like we have a getPlayerSave, I'm going to create a function called usePlayerSave. So usePlayerSave, and it takes as input the player save structure, and then we're going to split it and we're going to start using it. So obviously, when we load this data, we want to set the player's transform, their weapon, and so on. So I'm going to first check if this transform is not equal, or if it is equal. I can't do not equal for some reason. Okay, so if this transform is equal to the 0 transform, so if everything is 0 on this transform, that means it's not set. So that means that we received information that is incorrect. So we're not going to do anything in this case. This usually means that the save file exists, but there is no data for the player. So we're not going to do anything. So now on false, this is when we actually do something. So if there is a save transform, then we're going to set actor transform to our player save transform. And the weapon class, we want to also check, is this valid class? Because maybe the player wasn't holding a weapon when they saved, so this will be false. So if this is a valid weapon class, we just want to call equip weapon. This is a function I already had that takes the class and equips it based on that. Great. And now the health and the rotation. So we want to just get this variable set health and set it here. Make sure to do it on false as well, because yeah, if the weapon is not valid, we still want to do the other things. And finally, the control rotation, we can call set control rotation. Is that a thing? No. So we have to get our controller and then call set control rotation on that. And then just plug this in. Excellent. So now we're using the data that we have, but we're not calling this function anywhere. We created the function to use data, but where do we call it? So in our event graph here, on begin play. So on begin play, I'm just at the end here. What we want to do, the first thing is get our game instance and call our GetGameData function. And I'm going to check if this is valid. So if we do indeed have some saved data, I want to use, what was it called? Use save data, use player save. Yeah, we called it use player save. And the player save we can just get from here. Player save. Excellent. So now if I play, I'm at the second checkpoint. Lovely. So if I take some damage, let's say I'm going to decrease my health and go to a third checkpoint, it prints on the top left that it saves, close the game, start again. I'm at the top and my health is decreased. Great. If I'm holding a sword and I go down here, I saved again, I reached a checkpoint, close the game, play. I'm at this checkpoint and I'm holding the sword and my health is low. Perfect. And even the rotation. So I'm going to stop, well, whatever the rotation that I reach the checkpoint at. So I'm going to look in this angle and go to the checkpoint, stop the game, play, and the camera angle starts at this exact location because we're saving the control rotation. Awesome. Now, one thing we can do here is in our checkpoint, instead of this print, let's play a sound to let the player know that something happened, that their game saved or something. So we're gonna play sound. Let's use this that comes with the starter pack. So now if I go to any checkpoint, a sound plays to tell me that something happened. Great. So by the way, now if I right click and say play from here or something, that doesn't work because as soon as the game starts, it loads the data. So for testing, you probably want to delete the saved data to be able to start fresh again. So I'm going to show you how to delete this file. So if you go to your project folder and open the folder called saved, you'll find another folder called SaveGames. And then you'll find the name of the slot that you created. So we have slot1.sav. And if we just delete this and then go back to our game, then everything starts from scratch. So this is how you would do it. All right, now the interesting part, the cubes. So we can see here that as soon as the game starts, there are 3 cubes that spawn, and they weren't there as part of the level. And when I press C, I can spawn more cubes, and when I press X, I can delete these cubes. And of course, I can push them around. So if you recall in our BP save game, the data structure that we chose is an array of transforms. So what we need to do is store the transform of every cube in this array when anything happens, when a cube spawns, when a cube is destroyed, or when a cube's location is updated. So just like we did here, so in our interface, just like we have a SavePlayer function, I'm going to add another function and I'm going to call it SaveCubes or whatever. And all it takes is the async param only. And then back in our game instance, this is where we implement all of our save functionality. We are going to double click on the SaveCubes and implement this interface. Now, I'm going to take a simple approach here. I'm going to show you what this looks like. So first, I'm going to get all actors of class. So I'm going to get all of my cubes. What was it called? BP cube. And I'm going to get all of their transforms and put them in the array. But first, we actually need to clear the array. So get our save data. Get our SaveCubeTransforms, and call clear. Clear just empties the array. All right. And then loop over this array with a for each loop. And for each element, we get our cube transforms array and do add unique, which just adds a unique element. And the element will be the get actor transform. And once we're done, so on complete here, we want to save. So we just call SaveGameData and pass in async or not. Now, what I'm doing here is I'm going to update the location or the transform of all the cubes when any of them change. Now, obviously, if you have tens of thousands of actors in your level, don't update them all needlessly when only one changes. Have a unique identifier, find out which one has changed, and only update that one in the array. But for my use case, that's not going to have any negative performance impacts. I tested it with 2,000 cubes, and the performance impact was negligible. So I'm just going to follow this approach. And let's comment these and call them custom save functions. All right, so now let's go to our third person character. This is where we spawn the cubes. And now actually let's start with the 3 cubes that spawn when the game starts. Right, so as soon as the game starts, there are these 3 cubes. And these spawn in the level blueprint. So if you're on the level, you click on this icon and go to open level blueprint. Here, as soon as begin play, I just spawn 3 cubes randomly, right? So when I'm done spawning them, right here, if I get my game instance, and I just call SaveCubes, say I just do that, then they're now saved in my file. So every time I start, let's say I'm going to even go back here now and delete this. Let's actually delete everything. It's empty now. When I play, my cubes aren't there because their location is saved, but we are not using them from our save data. So back here in our level blueprints, I'm going to first, actually this is going to be our default if we don't have any cubes. So I'm going to keep this for now. But first on begin play, I'm going to first right click, get my game instance and get my game data. And this actually should be called get saved game data, but that's fine. And I'm going to get my cube transforms. And I want to check if this array contains anything. So I'm going to get the length of this array and check if it is greater than 0. If it's greater than 0, then this array has something in it. If it doesn't have anything, I'm just going to do the default that we did here. But if it does have something, then I want to spawn the cubes based on this array. So I'm going to loop over this array, do a for each loop. And for each transform element, I'm going to spawn a cube. So just take this, copy and paste it here. Recombine these because this was one transform object. And then just say spawn transform. Perfect. So now you see my cubes are there. And if I delete this, which initially spawned them, now we spawned them and we saved them, so I don't need this anymore. If I play, the cubes are still there. So that means we're using them from the save file. If I go to my save file and I delete it, and I stop the game, and I play again, the cubes aren't there. So it's good to keep this default. So if the cubes aren't there, we spawn the 3. So there's always these 3. All right, but now if I spawn cubes with C, they are not there. And if I go to these default cubes and I delete one of them, and I play again, it's still there. So we need to update them on spawn and on delete as well. So going back to our third person character, here in this is where I press C and I just spawn a cube. Right here, I'm just going to do the same thing, get GameInstance and call SaveCubes. And by the way, for these, I'm going to make them async because you want the loading to happen while the game continues. It's very unlikely. So you see in a lot of games, there's an icon on the bottom. They say don't close the game. If you see this loading icon, this is usually because it's doing asynchronous loading and it's also loading to a cloud. So this is what we're going to be doing. And we're also going to add this loading indicator at the bottom at the end of this tutorial. All right, and also I want to copy this and paste it here. So when we press X and we delete a cube, also save cubes. Great, so now I'm going to spawn a bunch of cubes and I'm going to close the game, start the game, and hey, look, my cubes are there. Now, if I delete this cube and I delete this one too, stop, start, they are deleted. Perfect. Now, the last thing we want to do with the cubes is to update their location. So if I push this cube away, or I push this cube away, and I press play, they are not pushed. They're in the same location. So we need to also save our cubes when they are updated. So how do we do that? For this, I'm actually going to do it in my cube actor. So we have BP cube here that does nothing, it's just a cube. And I'm going to search for the event on component hit on this static mesh. This is called whenever the component is hit by any actor. So in this case, the player pushing it. And when the cube is hit, I want to keep periodically checking the velocity of the cube to see when it stopped moving. And as soon as it stops moving, then I save that location. So to do that, I'm simply going to set the timer by events. I'm going to start a timer. Every 0.1 seconds, I'm going to check for the velocity. I'm going to set it to looping. And I'm going to promote this to a variable, we'll call it check velocity timer or something, so that we can clear the timer once the cube stops moving. And I'm going to create a custom event here, call it check velocity. And we're just going to get the velocity of the cube and get the vector length. What was it? Vector length without get? Yeah, just vector length without get. So the vector length is the speed, because velocity is speed times direction. So if you just get the length, you get the speed. And we're going to check if the speed is a very low number, like less than 3. That means, yeah, the cube is stopped or is stopping. So if that's true, we're just going to clear this timer. So call clear and invalidate timer and pass in the variable that we created for the timer here. And then we're going to save. So get our game instance and just call SaveCubes. And this is, again, the beauty of using interfaces, no casting, and we can call this from anywhere. And let's do it async as well. All right, so let's knock around some cubes. I'm going to knock this cube around, wait for it to stop moving, and then I stop the game, play again, and would you look at that? The cube has moved. Get all these cubes out of my way. Stop the game, play, cubes are moved. Now, obviously, if I stop the game while the cube is still moving, like this, it won't move because we only save when it stops. But that's fine in our use case. So as soon as the cube stops, I can save and it's going to be in its new location. Awesome. All right, now I want to add the loading indicator, the saving indicator that I told you about that appears in the bottom right of the screen to tell the player that their game is being saved asynchronously. So to do that, I'm gonna go here and create a widget, user widget, and call it w underscore saving game. And let's open it up, search for a canvas panel, throw it in here, and we're just going to put some text. So search for some text, and the text is going to say saving game ... And let's anchor it to the bottom right, change its position to -50, -50, alignment 1, 1, and size to contents. All right, so then we want to show and hide this widget when we're saving. And that means in our GameInstance class here, we want to add a reference to this widget. So our saving widget ref. And this is going to be of type W underscore, what did we call it? Saving game? Yeah. So just an object reference to our widget. And let's create 2 custom events here. One to call show saving widget, and another custom event to hide saving widget. So for showing it, we're going to get this widget reference and right click, convert to validated get. So if it is valid, then just set the visibility to visible. And same for the hide. If it is valid, set the visibility to hidden. All right, so for the show, if it is not valid, then we want to create it. That means we're creating it for the first time. Create our saving game widget, and then add to viewport. And of course, in the hide, if it's not valid, we don't need to hide anything because there's nothing there. Okay, let's add a comment here. Just call this UI elements or something. And now when we're saving asynchronously, get my cat out the way. Oops. When we are saving asynchronously here, so again, we only want to do this on async save because it doesn't make sense to do it on synchronous because it happens instantly. So when we first start to save, we're going to show our saving widget. And when it's completed, we're just going to hide our saving widget. And that's pretty much it. Yeah, let's see how this looks like. So now, if I go to a checkpoint, nothing is happening. Oh, wait. Something is happening, but that is not correct. Let's see what's going on here. We hide it, well, we show it if it's showing, and we hide it when we want. Oh, we actually never set the variable in the first place. So over here, we want to set the actual variable. All right, because now this is always invalid because we never set it. Now let's take a look. I'm gonna go up here. Still nothing, right? I don't see anything. What if I move these cubes? Oh, maybe the checkpoint is not doing async loading. Yeah, so okay, it's happening with the cubes. So if you look at the bottom of the screen, you'll see it for a very short period of time. So I'm gonna move a cube, or gonna spawn a cube, or delete a cube. So you see saving game shows up for a very small period of time. And this is the time it takes for the save to actually happen. So it happens fairly quickly. But for our checkpoint, we didn't click async, and that's the only difference. So now, when going up a checkpoint, yeah, you hear the sound and you see the indicator. Obviously, if you're making a game where you save something to the cloud as well, then this async duration should also include the time to request to the server, save the file, and get a confirmation that it is saved. So that's why in most games you see the loading indicator taking a lot longer, and also because they have larger data than what we have now. And as always, thank you all for watching, and for my Patreons, I will be adding an extended version of this video where I show how to use the async loading functionality on the GameInstance init so that you can load a huge amount of data in the beginning of the game and have it run in the background while we show a nice loading screen. And this extended video will be on my Patreon along with all the source code for this project and every other tutorial that I've made. So if you're interested, go there and check it out. And I'll see you in the next one.